In this lesson, we're going to look at how derivative can help us to find the maximum or minimum point on a graph, or how we can use derivative to find the maximum area or to minimize the cost for some real-life applications. Now, going back to the previous chapter, we've been talking about using derivatives to find the slope, to find the concavity, to find all these other things. So if we are to find the maximum point to maximize something like the area of a certain problems, what we can do is to use differentiation to find the critical point. And the critical point will eventually give us the maximum point on your graph. So here in example number 1, we have a farmer having 2,400 feet of fencing, and he wants to fence off a rectangular field that borders a straight river. So we've got a straight river on one side, and then on the other 3 sides, you're going to use some fence to create a rectangular area. What are the dimensions of the field that has the largest area? So in this case, we are trying to maximize the area of this fenced area. And we also know that finding the area of a rectangular shape involves the multiplication of length and width. So if we can set up an equation that will have y equals something in terms of x, we can then differentiate this function, find the critical point, and then that critical point will either give us the maximum or the minimum, and we will then check whether it is maximum or minimum using a number line. So going back to this picture first, if we are to find the area of this rectangular shape, I need to start with some variables. Let me call the short side as x, and that means on the other side, the first side of this rectangle would then be 24,000 minus 2x. So in this case, if we have the length and the width in terms of x, we can then come up with an expression for its area. And if you want to find the maximum area, we can then differentiate this particular function. I can consider this as y equals 2,400x minus 2x squared. And differentiating this function will give us 2,400 minus 4x. For this to be the largest area, or the minimum, the smallest area, we don't know yet, we can set this to 0. Using y prime equals 0, we'll be able to find the critical point. And therefore we have x equals 600. And that means if I have x equals 600, the length in this case would then be 1,200 feet. Now to check that this will actually give us the maximum area, you can use a number line to check if the left hand side here will give us a positive slope and the other side give us a negative slope for the f prime function. So you can choose numbers such as 0 for x, plug it back in, and in this case as x equals 0, we do have a positive value in this case. So the slope in this case will be positive. And then I can use x equals 1000, just random number. Plug it back in, and you end up getting a negative value, and therefore we do have a maximum point at x equals 600.